For most of history, the moon was thought to be completely dry, a grey, lifeless rock hanging in the sky. Even when astronauts brought back lunar soil during the Apollo missions, analysis showed no signs of water. But as technology evolved, so did our methods of investigation. In the late 1990s, NASA's Lunar Prospector hinted at the presence of hydrogen at the moon's poles, which raised the possibility of frozen water. However, the evidence wasn't strong enough. For definitive proof, space agencies around the world began a more focused search. And one of the most significant breakthroughs came not from the United States or Russia, but from India. In 2008, India made a giant leap in lunar science with the launch of Chandrayaan-1, its first mission to the moon. This mission, led by the Indian Space Research Organisation, or ISRO, was not only a demonstration of India's technological capabilities, but also a pivotal scientific endeavour. On board Chandrayaan-1 was a NASA instrument, the Moon Mineralogy Mapper, known as M3, which used infrared spectroscopy to scan the lunar surface. What it found was astonishing: clear signs of hydroxyl and water molecules embedded in the surface soil. For the first time, scientists had chemical evidence that water existed on the moon. This landmark discovery, credited to a collaboration between India and the United States, fundamentally changed the narrative about the moon's dryness and positioned India as a major player in deep space exploration. The momentum continued. In 2009, NASA launched the LCROSS mission, which intentionally impacted the moon's south pole. The debris plume it created was analyzed and confirmed the presence of water ice in permanently shadowed craters, areas that never see sunlight and where water could survive for billions of years. Yet it was India's Chandrayaan-1 that laid the groundwork for this mission by identifying where to look. Without ISRO's mapping and detection, LCROSS might not have known where to target. This international synergy showed how global cooperation can yield powerful scientific results. Since then, missions such as NASA's Lunar Reconnaissance Orbiter and the airborne SOFIA Observatory have continued to build on this foundation, detecting water even in sunlit regions of the moon. The mystery of lunar water was no longer a question. It had become a confirmed reality, and India played a defining role in that revelation. The confirmation of water on the moon has profound implications, not just scientifically, but practically. Water is essential for sustaining human life, growing food, and even manufacturing rocket fuel through electrolysis, breaking water into hydrogen and oxygen. This means that one day, astronauts might not have to bring all their supplies from Earth. Instead, they could harvest water directly from the lunar surface, making long-term habitation and exploration much more feasible. Lunar water could be the cornerstone of a sustainable presence on the moon, enabling the creation of fuel depots, greenhouses, and life support systems. It's the difference between a temporary outpost and a permanent settlement. India continues to play a crucial role in this unfolding future. In 2019, ISRO launched Chandrayaan-2, a follow-up mission that included an orbiter, lander, and rover. While the lander Vikram unfortunately crash-landed during its descent, the orbiter has remained operational and continues to send back high-resolution data about the moon's surface, including its polar regions. The Chandrayaan-2 orbiter's dual-frequency synthetic aperture radar is among the most advanced tools in orbit for detecting water ice beneath the surface, a key capability for planning future resource extraction missions. And ISRO isn't stopping there. The upcoming Chandrayaan-3, which successfully landed in August 2023, marked India's historic first soft landing on the lunar South Pole, a region rich in water ice. This made India the first country to land a spacecraft near the moon's South Pole, a major milestone not just for ISRO, but for all of humanity's efforts to access the moon's most valuable resources. Looking ahead, India has ambitious plans to collaborate with international partners and contribute to lunar infrastructure. With a proven track record of high-efficiency, cost-effective space missions, ISRO is uniquely positioned to support future lunar habitats, robotic mining systems, and possibly even joint human missions. India's achievements are not just scientific, they are symbolic. They represent a new era where emerging space powers shape the global narrative. The discovery of lunar water, driven in part by Indian science and innovation, has placed the country at the forefront of a coming space renaissance. The moon, once viewed as a silent stone in the sky, is now a place of hope and opportunity. Water, the source of life, has transformed it from a relic of the past into a gateway to the future. And thanks to the efforts of ISRO and its international collaborators, we now know that our nearest neighbor is not a dry wasteland, but a world full of promise. This is more than a scientific breakthrough, it's a turning point. From ancient myths to modern missions, India's journey with the moon continues. And in this next chapter, it leads the way toward a future where the moon becomes a stepping stone to the stars.